Hey everyone, we're going to continue with 5.3. This is page 5. Going to try number 12. So if you have to find the 6 trig functions of an angle 315, follow along with those steps. First step is to draw it out and get that triangle drawn. So maybe I'll blow it up here a little bit. 315 is in quadrant 4, right? Because think about, 90, 180, 270. It's 45 degrees past 270, right? So it's going to be in quadrant 4. Draw that triangle. And this reference angle right here is 45 degrees, right? That's, because you go 270 plus 45, that'll be right at 315. Okay. So once you have your triangle drawn, identify that as a 45, 45, 90, because if that's 45, over here is 45. It's a 90-degree angle because you drew it that way. And then use that special triangle, 45, 45, 90. What I always do is make the legs 1 and the hypotenuse square root of 2. That's always what you're going to use for a 45, 45, 90 triangle. Okay. And then put in negatives if there are any. This is positive because you're going to the right on the x-axis, but the y is negative because you're going down. So anytime you go down or left, you're going to put a negative. Okay. And then the r, the hypotenuse, is always positive. Alrighty, now we can just find our ratios and then rationalize if needed, right? So sine of 45, sine of 315, is y over r, or opposite over hypotenuse. So either way, you're going to see a -1 as the y, or opposite, and the square root of 2 as the hypotenuse, or r. And then rationalized -√2 over 2. Okay. Cosine would be the same. That's just x. So it's positive. So I guess not the same, huh? Positive 1 over √2, because now you're using the x over here, okay? Or adjacent to the reference angle. Positive √2 over 2. Tangent is y over x, -1 over 1. Opposite over adjacent is the other way to see that. So -1, okay? So those are the main three, sine, cosine, tangent. And then for the others, just flip those over, right? So cosecant is the reciprocal of the sine. So that's going to be √2 over -1, or -√2. Secant is the reciprocal of cosine. Flip over the one that's not rationalized. It'll save you some work. √2 over 1, that's √2. And then cotangent is the reciprocal of the tangent, 1 over -1, still -1. Okay, so those are the reciprocals. All right, so I think we've got this going now. I would encourage you to practice with these other two and just try them on your own. But before you do that, let's just draw them, because that's the key, right? So -210, it's going to be 180. Notice we're going clockwise, and then 30. So there will be a -210 right there. Okay. Notice your reference angle is 30 degrees, and you have a 30, 60, 90. Sorry, that's not very legible. That says 30. Okay. Right triangle, and you're good to go. Just got to label it. Remember how to label a 30, 60, 90? Opposite is 1, hypotenuse is 2, and the x value or adjacent is √3. In this case would be negative because you're going left. The 1 is positive because you're going up. All right. And then once you have that, it's just getting the ratios for your 6 trig functions. Okay. Let's draw the other one, and then I'll let you do the rest. 765. Okay, so that one has some rotations in it, right? We're going positive, so it's counterclockwise. There's a 360. So first step is maybe just take a 765 minus a 360. And you've got 405 left. All right, so still has 360 in it. We go another rotation. So minus another 360. And you're left with 45. So you're gonna go another 45 degrees. All right, so there's that triangle. And that reference angle was 45. Maybe to make it stand out a little bit, I can put it in red, but this would be a 45-degree angle right there, right angle. So that's 45. This one's a 45, 45, 90. 1, 1, root 2. Everything's positive because you're going right and up. Okay, I'm gonna pause, let you work on that, or maybe pause your video, work on those, see if you can get them, and then I'll just put the answers here in a minute. So go ahead and pause your video before the answers appear if you want to try it. Okay, so here is the ratios, what you come up with. Again, for those ratios, stick to the 5.2 definitions like x over r, y over r, etc. Or you can think opposites, adjacents, and hypotenuses. And hopefully that matches yours. If you have any questions on those, please let me know. Shoot me an email and I can help you out and explain further. Okay, so let's continue on with a different type of problem. This is page 6 now. We're going to look at the opposite, right? If you're given a ratio, can you find some angles such that that ratio is true? So this one is sine theta is -1/2. Okay, and we want anything in the interval 0 to 360 degrees. So the first thing I look at is the fact that it's -1/2. There are two places where sine is negative. Sine is associated with a y value, and y is negative below the x-axis. So in quadrants 3 or 4, right? So there should be two answers here, one in quadrant 3 and one in quadrant 4, right? Here and here, okay? And again, that's just because it's a negative number, right? Sine is negative in quadrants 3 and 4. Now I'm going to think about what that triangle would have to look like for a ratio to be -1/2. Remember, sine is y over r. So that would be a -1 here and a 2 there. Same over here, -1, 2, right? And then I can see now this is a 30, 60, 90 triangle. By Pythagorean theorem, this is going to be √3. Right? Or those three always kind of go together, right? -1, √3 as the legs, and 2 as the hypotenuse, okay? And then opposite the 1 is always a 30-degree angle. So the reference angle here, let's put that red, just because I can use colors, right? Are 30 degrees. Those are the reference angles. Okay, and now I can just figure out what that angle is. And then the quadrant 3 would be starting here in standard position all the way around. Right, so that straight angle 180 is here, right? So this would be 180 plus 30. And 180 plus 30 would be 210. There would be the quadrant 3 angle, right? The quadrant 4 angle, I could think of it in two ways. I can start and go all the way around, right? Like that, right? Or I can just think of it as 360 and just minus that, right? That might be the easiest way if you end up in quadrant 4. 360 minus 30, that would be a 330-degree angle. So those are your two angles such that the sine is -1/2, okay? If you're not sure about that, you can always, do like the problems that we did on the previous page, find the sine of 210. The sine of 210 is going to be -1/2. The sine of 330, also -1/2. Practice with another one, number 16. What about tangent is equal to 1? Okay, and then we have between 0 and 360 again. Let's get off the red and get back to blue. So where is tangent positive? Okay, tangent is positive in quadrant 1, because everything's positive in quadrant 1, and then quadrant 3, right? Because both x and y are negative in quadrant 3. If x and y are negative, negative divided by negative, positive, right? Because tangent is y divided by x. Okay, so I know I'm going to have an answer here and an answer here, right? And tangent is y over x, so that means x and y are equal. So let's just make them 1, right? And over here, it would just be -1 and -1. -1 divided by -1, +1, okay? And so notice if you did Pythagorean theorem, you're going to get square roots of 2 as the r, or those 3 that were linked together in a 45, 45, 90, right? 1, 1, root 2, just something good to have in the back of your mind. And then that just means we have a 45, 45, 90. That's a 45-degree reference angle on each of those. Okay, so I know one of my answers in that quadrant 1 is 45 degrees, right? For the quadrant 3 answer, I gotta think about what that angle is in standard position, and it would be 180 plus that 45 degrees, 225. We got it. Those are the 2 answers. Okay, so it takes a little, working backwards detective work there to get it figured out, but kind of cool. Okay, so what we've been working with so far is exact values. And so exact values are such that you don't use your calculator, you just use the properties of 30, 60, 90 triangles and 45, 45, 90 triangles, and give things in terms of square roots and such. Anything else besides those special angles, you'll have to use a calculator. For example, if we look down at the next example, number 17, right? We have sine of 96 degrees. I'm not going to be able to draw that and then figure out the ratios of the sides of that triangle. This one, we're going to have to use technology. Back in the day, before calculators, they'd use tables. So a lot of trick books, you have tables in the back that you look it up, but nowadays it's all just calculators. The key here is make sure your calculator is in degree mode, because these are degrees. Your calculator has 2 modes, degrees and radians. We'll do radians later. For this chapter, we're in degrees. So make sure your calculator is in degree mode. Kind of depends on the calculator you have. My demos are going to be using the TI-84 graphing calculator. So if you have that, it'll match. If you have anything else, play around with your calculator, look at your user manual, or even Google how to change the mode of a TIX with IIS or whatever you have, right? And something will come up on YouTube that will walk you through it. Okay, so let's find the sine of 96. For these, I'm just going to share my screen where I have my calculator up. So I'm gonna try that now. Let's see if this will pop up. Okay, so hopefully you see my calculator here. This is a TI-84 plus. If I'm going to find the sine of 96 degrees, the first thing I'm going to do is just make sure my mode is right. So there's a button that says mode, and oops, it's in radians. So I got to go down and click on degrees. So I just highlight degree and hit enter. Okay, now I'm in degree mode. Okay, and then now I can exit that, or I can just quit. So I hit second, quit. Okay, I'm back to my main screen. So it takes a little getting used to. If you haven't used these calculators or any calculator, just get to know your calculator here. But now it's pretty straightforward. Your calculator should have a sine button. So on mine, I have to hit sine first, and then I just type in 96 and make it look good. I can close the parenthesis and then hit enter, and then there would be my answer. Okay, so pay attention on these, how they want you to round, right? Some of these, they go pretty extreme. I think in your homework, it'll say round to like 8 decimal places, which is a little crazy, but that's what they do in this textbook. So if I'm going to do 8 decimal places on this one, all right, 1, 2, 3, 4, 5, 6, 7, 8. I got to round to that 9. Oh, a 5 means round up. I got to bump that 89 to a 90, right? So 99452 Okay. And then that's it. All right. The next one on the handout is the cosine of 38 degrees, 14 minutes. Okay. Some calculators have the notation minutes. But in general, a quick way to do that, let me just show you that this will work for any calculator, whether or not you have it or not. If I do cosine 38, that 14 is 14/60ths of a degree. So what I'm going to do right within the parentheses, I'm going to do plus 14 divided by 60, 14/60ths. Okay, and that's a pretty simple way to do it. That way you're not trying to hunt around for a minute function. Okay, you just type it in just like that. Works cool, and then enter. All right, and then round that guy to a zillion decimal places. Okay, and I'll let you work on that one. The next one is tangent negative 164. Okay, so I go tangent. For negatives in a lot of calculators, you can't use the minus sign, right? Like if I try it, I do, well, it's just minus 164. Gives you an error, okay? It doesn't read the minus as a negative. So let's go back to it, right? And it even highlights, hey, this is a problem here. This is the one you want to use right there, a negative 164. That gives it to me, okay? And then round to the appropriate decimal places. If you're going to do cosecant, so number 20 now, is cosecant of 334 degrees. That one, you don't have a cosecant button, but you know that the cosecant is the reciprocal of the sine. So for cosecant, start by doing 1 divided by, and then do sine 334. Okay, enter. And then there would be the answer. Round that to 8 decimal places. Okay. For secant then, secant on the next one, I'm looking at number 21 on your handout, secant negative 452. So I have to do 1 divided by, the reciprocal of secant is cosine, negative, use the negative button, 452. And then there it is, okay? That last parenthesis, you don't really need it. Kind of get lazy and I don't close my parenthesis. And then finally that one, that number 22, cotangent. Cotangent is the reciprocal of tangent. So 1 divided by tangent, and then it's 57 degrees, 35 minutes. 57 plus 35 divided by 60, all within the parenthesis there. Okay. And then there would be the final answer. All right. One last thing, we'll finish off this page 6. If you have to go the other way, so hopefully you have the handout and you can see it, like number 23, the sine of what angle is 0.457324. That's when you're going to use these buttons where it has inverse sine to the -1, it looks like. Okay, so for that number 23, to access that key, I have to hit the second function first and then that button, and I'll see the -1 appear. All right, and then I put in the decimal. Okay. And then there would be the angle, right? Between 0 and 90, round your decimal to 6 decimal places. All right. So for tangent, now I got it, an inverse tangent. All right. And then I put in the number 3.90554. Okay. There would be that one. All right. And then finally, I have secant is equal to 2.51867. Okay. I don't have an inverse secant button, but I know that the cosine is the reciprocal of that, right? So cosine of theta is 1 over 2.51, blah, 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 right? So I could do second cosine, and then in the inside the parentheses, 1 divided by that number, 2.51867. Okay. And then there would be your final answer, right? And you can check these, you could verify that the secant of 66 degrees is 2.51, right? Etc. and all those. All right. So that's a good stopping point. Hope that helps. That's the end of page 6. Going to do one more little video for that last page, and then we'll be done with 5.3. Okay. Hope all's well. Send me questions if you got any.